Hi, is it 3 o'clock? Of course, I am muted till it's the 3. Can you see me as well? Anything that I should change? Hmm. Come back. See a lot of familiar faces. Those who I saw yesterday, welcome back. Today's lesson is for P5 and P6. Of course, P3, P4s are still welcome. Like I said, everybody is welcome to learn science at any time. Everybody can hear me? Thumbs up. Yeah, weekend they decide to take. Okay, all can hear me? Or still muted? Okay, okay. I hit some video thumbs up. I can see Kevin Narayan using his real video thumbs up. I'm sure all of you can. So the reason I allow you all to use the video, okay, some teachers like to off. I let you all on, okay, because I want to see your expression. I see minions and transformers here. Okay, I want to see your real. Okay, it's not that clear. How many of you think it's not that clear, the voice? Then we can try again. You can type a private message to me if things are not going well and you can't hear me. If you can hear me, you can say it's all is good also. It's a bit laggy. Okay, I think it's the internet. I can't hear clearly. Okay, so let's just give us 1 minute. Let me just have a look at my internet and come back. Let's see everything else. Okay, get on for about 10 minutes and see how it goes. Let's start with the first slide. Water and its cycle. Okay, you can also, in the private chat when you have time, type to me what level you are from. Okay, let's say I'm from P5, I'm from P6, I'm from P4. I'm just here to have fun. So that later on, I can actually just check the messages to see where you guys are coming from. Of whether these guys who are with me in good today. Yesterday we did fungi and bacteria. Now next time when you see a topic like that in P3 and P4, you guys from P5 and P6 are welcome to join in as well. The reason is because P and P4 lessons are also tested in your might have forgotten many of the concepts and still struggle with the questions. So it's a good idea to come and visit us. Whenever I'm doing P3, P4, and its cycle has some misconceptions, okay? Usually the questions are not understood or the concept is not understood and you can't answer. So we actually gave you a homework, right? How many of you actually did the work? You can also put up your hand or you can raise your hand or you can say thumbs up. Okay, good, because you'll be going through those questions and you will find out the answers and to see if you actually got all of them correct. My guess is one mistake from all of you. Let's see if you got everything correct. Okay, let's start the very first slide of today's lesson. Okay, is it still lagging? Because I do get some messages. Let 5 minutes pass and then maybe it'll get stable. Then we will see how it goes. Okay. Okay, you are expected to know a few things in today's lesson, and next week when you join me I will be actually continuing a little bit more about this topic itself. So today's lesson will only have these learning outcomes. Recognize that water can exist in 3 interchangeable states. You know what those 3 are, right? Okay, I'm not going to write the full form. All of you are clever enough to know. Or heat loss affects the state of water. Take note, we are only concentrating on water. Next, understand the term melting point and boiling point. And I also put water, ice, because we're concentrating on water first. Because once you know the water very well, because water is an easy to understand concept or a material or a matter, okay, so you can apply it to other liquids, other gases, other solids. So we need to start off with water because all of us understand water very well. It comes from our taps, which looks like this, okay. Hand means to write quickly and in short form, okay, so that you don't have to write long sentences. Of course, in the exams, then price or remember things. So water can exist 3 states, okay. Let's look at the bottom of the screen. What is the clarifying box below? Clarify. All things living things and non-living things, okay, so are all living things. Okay, since 5 minutes have passed, okay, let's not carry them with laggy lessons. I'm going to try and improve the connection of boiling. I want you to write down what is boiling. Exactly, copy. But you must write boiling happens when what changes what. And this temperature is called what? Okay, copy exactly and write down for boiling. You can write it on my chat group as well or on your piece of paper anywhere. Okay. Melting happens when water changes state from solid to liquid at a fixed temperature. How is it? Okay, better? Cool? Yes, good. Yeah, okay. I got the thumbs up from a lot of people to say it's good. And okay, I got some answers to the question, which is boiling occurs when water, what? Not water, right? Is it water? Melting happens when water changes state from liquid to solid. Now, do you change any of these? Do you change any of this to anything? Like, did you change this or did you leave it? Okay. Did you change this or did you leave it? Okay. And then did you change this? Obviously, the fixed temperature is now called boiling. Okay. Melting. Now, this also you must change. Boiling happens when water changes state from liquid to gas at a fixed temperature. Am I right? Okay. Okay. Thanks for your feedback on telling me it's much better now. So I'll also try to talk as clear as possible and you guys can let me know. Okay, so we highlighted how melting and boiling can happen. Okay, there's going to be a very, very important question on this coming up soon. So I'm going to ask you to pay good attention at this part. Okay, don't go away and start playing with the videos. If you guys are going to play videos and put lots of funny things on my video for other people to see and distract them, then it's very easy for me to just kick you out of the room, right? So I did ask your cooperation in trying to just stay focused on the video. I let you use your video for the reason where you can show me thumbs up and show me that you're smiling, you're enjoying the lesson, and etc. If you want to make funny faces, then I have this power to just kick you out of the room, because it's all just a click away. Okay, I can see which person and then just say this video is bad. I'm just and bye, you go out and you cannot come in. Okay, water gains heat from its surrounding now. Okay, that was point A. If is it going to be the same if we talk about boiling? Yes, right? Water gains heat, right? Can you tell me, if I go back to the circle on top, why we didn't say ice here? Okay, this is important to realize. Huh? Why didn't I say melting happens when ice changes state from solid to liquid? Can also or cannot? You can type to me. Just say can or cannot. Can. Cannot. Okay. I don't know. Cannot. Okay. If we really look at it, okay, the matter that we are talking about is water, which can exist in 3 states: the solid, the liquid, and the gaseous state. So in its liquid state, we do call it water. In its gaseous state, we call it ice. Sorry, in solid state. In its gaseous state, we call it okay, I'm not doing any question yet. These are just notes. Later, I'll be doing the questions. Okay. Yes. Hello. What is the name here? Okay, I underline so you know. Can you fill up for me? Type for me now. Kevin Narayan has answered. JJ has answered. Neetu Joyce, Chang Kagan, Adil. Okay. I've got answers. A lot of answers. Oxygen. Okay. Okay. The more 2 common answers I get are okay, these are the 2 common answers. Now, since all of you know these are the 2 answers that the teacher has written down, will you agree that both can be accepted or only one can be accepted? This is very important because if you don't know, water, steam. Depends, okay? Or people say depend, one can be accepted. Actually, both are the same, okay? It's just that one is usually at 100 degrees. Not exactly both the same, okay? The steam is at boiling point, okay? Water vapor is at its gaseous state, but it's not at boiling point. This is the difference. Because I didn't ask you, I didn't tell you that water has boiled, did I? I didn't say I put the water in the boiling of the kettle to boil it. If I did, then the gas that comes out at 100 degrees Celsius will be called steam. Okay, it's at 100 degrees. Steam will always be at 100 degrees. Okay, because it's boiling and steam is coming out. Water vapor can be at any temperature. Remember, you guys have done evaporation, and water can leave the surface as gas as well. At that point of time, you don't call it steam because it's not 100 degrees. You call it water vapor. Clear? Okay, this is important, so I had to ask. Okay, so and all that. We will be looking of some point. There are different processes, right? So it's a different process for, but the same. It occurs at the same temperature. So it's a different. So here they are different. That's because it's the same point of temperature. We call the melting point will be exactly at the same point as the freezing point. And to understand that, that's why we take water as an example, right? Which happens at 0 degrees Celsius. No changes, whether it's melting point or freezing point is the same. It's just different conversion. Melting point is solid to liquid, and opposite happens liquid to solid. All right. So there are two different things we have to take note of when look at the question. Are they talking about melting? Full stop, nothing else. These are the two things you need to take note of. So when we say freezing is actually a process, melting is a process. We say state is changing. Okay. Then when you talk about point, there you go. The point is the temperature, the fixed temperature. So a lot of you still do not know the difference. So when you go through a process, then the process actually loses heat, or the melting will gain some energy, that's gain heat. Okay. You can always come back and watch this video again tomorrow when we upload it and put it up. So if there's no launch today, you can go through the whole thing when we upload it on the website tomorrow. Process of melting. Okay, see, they tell you it's a process. They tell you it's the process of melting. Take note, is now water so loses heat to its surrounding during freezing. So gaining heat and losing heat also need to know. This way is gain, so it's melting. This way is lose heat, is freezing. Very important, recognize this in. Then you can take it forward to matter, okay, other liquids and other solids and gases. Okay. Now boiling. Remember, I asked you at the very start of this lesson to write down what boiling is. This is exactly what you should have written. Okay, instead of that melting, right? This word should have been ice over there. And then I did go through the solid liquid. I forgot to tell you that this, why? Because water is the name of the matter. The names ice, water, and steam, water vapor refers to the states. So what's the name of the person? It's still water. Okay, whether you are, it's just like you, your name is Kevin. Okay, then you become angry, you become sad, you become emotional. You can become many states. So these are the states. But does it change your name? Your name is Kevin. We still call you the angry Kevin, the sad Kevin, but your name is still Kevin. So the name of the matter is still water. That's why we say boiling takes place when water, the name of this, whatever we're talking about, maybe we can talk about Ribena, we can say orange juice, okay, but the name must be there, okay, changes its state. Then we say this guy is changing its state from liquid to gas or solid to liquid, and then we may ask you what is the name of that particular state. Then we say steam, water vapor, and so on. Here we may say ice. Got it? Okay, just to make things clear, if you see, okay, earlier they said melting takes place when water changes its state, and you thought, oh, why didn't they say ice? So I'm clarifying that here. Okay. We carry on because it's the same thing that we just discussed. This can be gone very fast. Water gains heat. Okay, I want to go to the more important one. Again, this is the reverse process of boiling. If melting and freezing are opposites, then the opposite of boiling is condensation. Again, two different processes, they have the same point called the boiling point and the condensation point. Both will be occurring at 100 degrees Celsius. Okay, take note of that. You must be able to draw such diagrams. So again, do things like this and do things like this. Okay, does it gain heat or lose heat? You must be able to fill up. And what the process called? you must be able to fill up. Okay, these are actually very basic, so I just don't want you guys to get wrong on the basics. Okay, especially P5s, you are very good in this. P6 are very good in this. P5s just started water and cycle, still have confusions, I've seen. So now is your turn to show me you're not confused by answering this question on chat for me. Okay, now, are you ready? Let's go. I'll only give you 1 minute, exactly 60 seconds. After that, I'll stop. My timer is running. Mm. 20 seconds gone. Are you writing it on a piece of paper or on my chat? Wherever is fine, because I'll be going through this question in detail as well. Okay, very important, because very, very commonly asked question. Yeah, time's up. Okay, state in your own words what is meant by melting point and boiling point. I wanted you to pick up, because all the way we only talked about melting and boiling, but we haven't talked about point. How to talk about point. Okay, remember we saw this very first 2 minutes. I already showed you this slide. Melting happens when water changes. Okay, melting point is the temperature on where water is going to melt. All this I've shown you. How to change this melting to melting point? That's the question. Okay, so let's look at it. I'll just show you the slides. Won't talk so much. You guys try to figure out. Okay, you see, when I change the word melting to point, what happens? I have to cancel a few things and add a few things. Okay, you see, the fixed temperature is here at the end, where I have brought it to the front. Can you see? Melting point is the fixed temperature, because we're talking about the fixed temperature, not talking about the process anymore. Remember, this is the process. This is the temperature. So you need to talk about two things. So in the exam, they tell you, define melting. Don't talk about the first one, the up one, or the down one. Which one? Define melting, you talk about the process. Define melting point, talk about the temperature. So you change. Melting point is the fixed temperature at which, see, I use the word water here. I didn't say ice. Water changes its state from solid to liquid. Very similar, but the key thing is to bring this forward. If you bring this forward and then using your English expertise, you can actually write the rest of the sentence quite well. Okay, so once you bring this forward, the rest becomes easy, right? That's what I wanted to point out for this. Very important. Okay, so at which, okay, water changes. This one, there's no water. I cancel out water. Why? Can anyone tell me why I cancel out water and change it to a solid? Changes from its state from or to liquid. That basically, I'm just removing this water and putting solid changes to liquid. You know why? Because the question doesn't say melting point of water. So if it says melting point of water, you use the word water. If it doesn't say melting point of water, then it's melting point of everything, general. Okay. So all solid go through melting. Very good. All solid. I already got response from some of you saying, yes, all solid. That's why I changed this water to, at which a solid can change into a liquid. Simple, straightforward. Why? My question didn't say water. So you, again, the third way they can confuse you. So not only did they confuse you by asking you between melting and melting point, they can say melting point in general, and then all of you will say, oh, I know this, very good. Melting point is when water changes from solid to gas, so to liquid. Oh, you put water, wrong. Why? We didn't talk about water at all. You put water, we will deduct marks, okay? Because you have to talk in a general sense then. So take note of that. Okay, so this is the final answer. After all the cancellation and messy work, is so short. Melting point is the fixed temperature at which a solid, right, changes to liquid. That's it. Simple, right? Yes, good. I hope you guys are feeling the emotion that I'm trying to put through here to get you to write the right things. Okay, I'm trying to help you guys, right? Otherwise, minus marks, you won't get the marks that you thought you will get. Especially a lot of you feel I wrote the correct answer, but after they get back the paper, silly mistake here, mistake there, because of these things. Okay, reverse process again. I'm not going to really focus here because you know I focused a lot on melting and showed you what you need to take note of. So freezing is the same thing, which is the opposite of melting. So we've already done this. Confusion. Okay, this is now we are going deep into melting now. Okay, if you can answer me what melting starts when, what? When does melting start? Okay, you have ice cubes, right? You take it out from the fridge. How do you know melting has started? Let's say I ask you, you must start the stopwatch when the melting started. How? Okay. When do you start the stopwatch? When you see the very first drop of water. It means because ice, okay, before this water came, okay, let me erase. Ice can be solid at what temperatures? Minus 20 degrees. I don't know where you go. You go to Antarctica, also the ice, your temperature minus 20, or your freezer is very, very cold, minus 20. It's usually not so low, maybe minus 10, more like it. Okay, it's still ice. I don't see any melting happening. Then minus 5 degrees. That means as long as you don't see water coming out at all, melting hasn't started. So you can actually gauge the temperature. The temperature must be below 0. Minus 1. Still haven't started melting, right? Now, when it starts melting, means the temperature has reached 0 degrees. Am I right? Okay. Melting, we're talking about melting, okay? The first drop of liquid that you can, now you stop the stopwatch because you know the temperature must be 0 degrees. And then you see more and more and more ice melting. And then you see this becoming like this, right? It's breaking down, and then you have a big puddle of ice, water. Am I right? Am I drawing good? Okay, you have water now. My biggest question to you is the temperature at this time. Now, let's say it has been melting for 5 minutes. Sorry. 5 minutes already. Remember, you started your stopwatch? 0, 1, 2, and then 5 minutes later, so much ice has come. What can we do? Okay, what can we say the temperature is? Nobody type. Tell me the temperature after 5 minutes. Remember, you started the stopwatch when it was 0 degrees Celsius. Now, after 5 minutes, the temperature is, because the ice is still here, there's still ice and there's still water. Am I right? There's a combination of both. There's ice plus water. What is the new temperature after 5 minutes? That's my question. The temperature is good that you guys are thinking. Okay, 5, 0. Okay, the fact that you don't know or not sure is why you are here in this lesson. Okay, because this is important again, and we will apply this to our questions in a while. Okay, very important. It's still 0 degrees Celsius. Why? You ask yourself, is the ice still melting? Yes or no? Yes. If the ice is still melting, melting can only occur at 0 degrees. It cannot occur at 1 degrees, 2 degrees, 3 degrees, 4 room temperature. No. So it's still melting until all the attention to where I'm going to erase. I'm going to, at this point, pay attention here. Pay attention here to the right side, the diagram. Remember my ugly drawing is going off. And I have water, just full of water. What has happened? Let's talk about it. Is ice still melting? Now, look at the diagram. No, the ice is not melting. It's finished melting. So that means it can go from 0 degrees, it can finally go to 1 degrees. Finally, because now it's water. And water has released itself from the ice. Like there's no more ice. Goodbye ice, goodbye solid state. Now I'm liquid, I'm fully water, I'm myself. So I'm going to 1 degrees, 2 degrees, 3 degrees, 4 degrees, 5 degrees, 6 degrees, 7 degrees, 8 degrees. Then will it stop at one temperature or will it continue? Which temperature will it stop, or will it stay at 8? Or remember, your time is going on, it's the water now. It will go and finally land up at the temperature that is the equal the room temperature, which is roughly, you should know, right? Around 25, 26 degrees Celsius. Why? Because your room temperature, let's say, is 25 degrees Celsius. It is exchanging the heat to this water. It's still gaining heat. So when it's gaining heat, okay, the temperature will raise until it matches the room temperature. Then there's no temperature difference. So it will not exchange any more heat. Therefore, the temperature will stop at the room temperature. I'm just giving a number. I'm not saying 25 is the exact. It could be according to the room temperature of your room, of your house, of the place you are. In my room, if my aircon is on, then it's 25 or 24. If it's really hot, it's 31 and so on. So it can change. So in the questions, they never tell you the exact temperature usually. They just tell you room temperature. Unless they wanted to calculate something, they may give you a number. Okay, like I gave you an example number. So melting starts. Let's finish this confusion by putting down the statements that we just discussed. Melting starts when the first drop of melted ice, remember the first drop, yeah, the first drop appears, and stops when the last bit of ice disappears. Bye-bye ice, bye-bye ice, bye-bye solid. Okay, so that's important. Next, therefore, during melting, water exists in both the solid and liquid state together. Remember, there's a solid plus liquid during the melting, and all of you said yes, melting is still going on. So both states are present until one state totally takes over. Melting is still going on. Okay, remember that. And finally, the same goes with other processes like freezing, boiling, and condensation. We only know 4 processes. Okay, so that's why. Okay, now teaser time. This label called, if they ask you in the exams, what will you label it? First answer from third answer is water vapor, liquid form, and so on. Just now, steam and water vapor. You never water inside. You didn't ask me. Okay, this is a very good science student. Sometimes you might have been honest. How about that? Okay, so mist is never part of this. Secondly, since it's a, okay, usually we put water, so that's why You must have thought, okay, what am I doing? What process am I doing? Boiling. So will you get any kind of water vapor, whatever you may call it, at any other temperature by boiling temperature? No, right? You will get it only at 100 degrees Celsius. Call the vapor, you see at 100 degrees Celsius. I already explained to all of you, it's called steam. Okay, I think some of you might have problems hearing me. No problem. Sometimes the internet goes in, and so we just, because my voice is coming through slowly. So, okay. If most of you paid attention in the first 10 minutes or 15 minutes when I discussed whether we use the term steam or water, when water is called steam, it's water vapor. Okay, water vapor is at any temperature, right? The moment it hits 100, we change the name to steam. That's all. So we know clearly that it's coming from boiling water. Okay, so this gas steam is invisible. Now there's another misconception. So that is not steam. So a lot of you put steam because I'm pointing to the part where you can take 5 seconds to look. Where is the steam? Is this thing? Okay. Is it clear now? Let me just so all of you are looking at this point where the steam is the part where it's invisible. Okay. And the part that you can see is not called steam, not called water vapor, is called condensed water. Okay. So this part you have to be very, very clear. Confusion. What are clouds made of? Very similar to what we just did with the kettle and the water. Okay. What do we do here now? Can you all label for me? Is the cloud? Okay, those of you who are going to say these are clouds, I'm going to mark you wrong. Okay. Because what are they made of? I already mentioned the word cloud option. Please tell me clouds. Okay, so that's why I'm going to mark you wrong. So what should it be? What are clouds made of? Tiny water droplets, gas, tiny water droplets. Now you see, we are going to give mark here, right? So we are going to give the answer here, but then you don't know. Some of you get it. Okay, let's say I have 20 participants here, but only 10 knows. So 8 of you are going to get it wrong. That's a lot of students getting it wrong. Okay, so after I just showed you, so this, can you see or cannot see the cloud? Can see. All right. So if can see, do you call it vapor? Now vapor and steam, no matter what, is cannot see. So how can you put any of these names here? So you cannot. So you must say this is the water droplets. From where? Okay, so that's why I said you cannot use the word water vapor, you cannot use the word steam, but you must use condensed water. Water droplets from condensed water. That's why you can see. So if I ask, where is the water vapor then? Can you label the water vapor? In the question, we may ask you part B, label the water vapor. Okay, that is going to be like this because it's the invisible part, cannot be seen. Okay, can? Good. Invisible. Take note. All right. Now we jump to the question time, which you all waited for. Okay. So those of you who have done the homework, time to look out for the answers and why you may be getting them wrong and how to do them. Those of you who have not actually attempted, you can actually attempt them together with me, where we will take note of all the points that we have discussed and apply it to the questions. Okay. You have to be faster if you haven't done this homework before. Okay, so you have a glass containing block of ice and water. Remember, this is very similar to the ugly drawing Ali drew earlier, which is some ice block is melted and some water. Similar, okay? So at this point of time, that's why you have ice at 0 degrees and water at 0 degrees. Some of you like, how come water can be at 0 degrees also? Because it's at the point, remember? And when it's not over yet, melting still going on, the temperature will always stick to 0 degrees, no change in temperature. Okay, this is important. So which one of the following is correct when water and ice were at 0 degrees? The ice will not melt. Hey, it will continue melting. So why will it not melt? So this is wrong. The ice will not melt as it did not gain heat. I said it will continue melting, right? It will continue melting, but it's gaining heat. Where is it gaining from? From your surrounding. Remember, your surrounding is, example, I'm going to use 25 degrees all the time just to keep it constant. I don't want to keep changing my room temperature. So if it's 25 outside, the heat is going to be absorbed by the ice, which is at 0. Okay, let me change the color here, which is at 0 degrees Celsius. So there is a heat exchange. So that's why it's gaining heat. We're not talking about what we already know what will happen. Then see, the ice will melt as it gains heat from the room. Yeah. Okay, and the ice will melt as it gains heat from the water. No. Okay. All right. Okay. Now, question 2. You know the answer for question 1, huh? Question 2. Table below shows melting point and boiling point of two substances. Very commonly asked, they will always give you the information of the substances and ask you whether it's a liquid, solid, or gas at that. So you just need to get the states correct at that part. Okay, P will be a solid, liquid, and a gas at temperatures below 6. That means at temperatures 2, 3, 4, 5. At 6, it will melt. Okay, take note. Then after it melts, it becomes a liquid, right? Then at 270, it will boil. So after it boils, it becomes a gas. So anything that is on this side is a gas. Anything on here is a liquid. Anything on this side is a solid. That's how you have to study your diagram. Okay. So now, which of the following shows the correct state of substance at 17 degrees and 450? So where is 17 degrees? Okay, let me pick one color. Yellow. 17 degrees is here. Okay, and here for Q. So that's why it will be a solid and a liquid. P will be a liquid and Q will be a what? Q will be a solid. Okay, at 17 degrees. Am I right? So all these answers are correct. Then at 450 degrees, we check 450 degrees P has become, where are we now? Here, I'm highlighting here. 450 degrees P has become a gas. So we have gas, gas. And what about Q? At 400 also become a gas. So gas, gas, gas. So there's only one answer that fits our circles, where it's A. Am I right? Okay. Next one. Mandy heated up a beaker of water until it reached the boiling point. She then removed the beaker from the heat source and the beaker of water in the ventilated room. So remember, just draw a simple diagram. This is water and it reached boiling point, 100 degrees Celsius. Is it easier to see if you have a diagram like that? Yes. And then she removed it from the heat and just placed it on the table. No heat. Okay. In a well-ventilated room. She took note of the changes in the temperature of water in the beaker for 20 minutes after she placed it on the table like that. So initially the temperature would have been 100 degrees Celsius. So it starts at here. So it starts at here. So that's why A, B, C, D, all of them start at 100 degrees. That's correct. If any one of them didn't start at 100 degrees, then we know that answer is wrong. But however, they started all at 100 degrees. So all answers are correct except the way the temperature will proceed. Will it stay at 100 forever? No, B is wrong. Will it stay at 100 forever? No, B is wrong. Because you have removed it from the heat. So the temperature will go 98, 97, 95, 80, and so on. So it should go down. It should get cool, right? A boiling water, go try it today, boil water and put it down. It should get cool such that you can drink. Therefore, A is also wrong. How come it got hotter? The temperature rise. This one is 100 or maybe 120. This one is 150 already, the temperature. Wrong. So it cannot go up because the heat has been removed. It can go down. Okay, so C and D option possible. Now D goes all the way to what temperature is it? 0 degrees. Does this water that you leave on the table back to it and you want to drink and it's already reached 0 degrees, is it become super cold water? Is it melting, become ice? No, no way. So that's why it's wrong. That's the difficult part where you have to choose between C and D. Many of you miss that D is actually going and reaching 0. And that's where you say, hey, it cannot be, it's wrong, you're out. It cannot go to 0, it must go to some temperature in 0 and 100, 100, nearer to 0, somewhere around 20, 30, you know, roughly in your head, it's about 30. We didn't even tell you what it is, but I know it's about 25, 26, 30, whatever number you like, but I would like to call it room temperature. So answer is C. Okay, this is what, I don't know how many of you got D as the answer. Okay, because you got confidence choose. Very important, right? What happens when ice cubes in the container are melting? Just need to read, okay? The ice cubes in the container are melting. The ice cubes lose heat, the ice cubes gain heat. Melting, huh? It's actually quite straightforward, okay? So don't need B, C, C. Some of you said B, some of you said C. B only, meaning this B only or this B. Again, a lot of you don't know whether to choose. You are supposed to choose A, B, C, D from the colored ones. Not B only means you don't write B. Then you take it as A and C only. So you can see there's a difference. Don't write B if it is B only. So let's look at the question answers options. The ice cubes lose heat. No. The ice cubes gain heat. Yes. Am I right? These two very easy. The ice cubes change into a gaseous state. No. Same thing like how just now you boil, it doesn't change to ice straight away. Here it melts, doesn't change into a gas unless you put it in a kettle and boil it. Enough heat must be given. This heat will only possibly just go from 0 to room temperature. Am I right? So that's all we can know about this experiment. They are just melting. Okay, again, is it going to room temperature? No. Why? Because it's melting. So it's not yet going to room temperature. It's just going to stay at 0 degrees Celsius all the way. Forever and ever. No, no. But I'm talking about during that time, maybe 10 minutes, during the time when it's melting. So we're going to talk about during the time when it's melting, nothing else. The temperature of the ice cube rises to room temperature. That's why this is wrong, right? You know why right now? Because it will rise when you leave it long enough. When it's melting, we're talking about melting. So a lot of you forgot to look at the question here. Star, 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 star. If you didn't see this, then you will choose B and D. Okay, you might have chosen C as your answer. Wrong. It's not that. The answer is only B. So answer is A. Okay, got it? Okay, like I said, it's still confusing. Okay, I already told you the keyword is here at the question where it's only during melting. Okay, always rewind this lesson and view it to make it clearer for yourself. All right, question 5. Similar, again, this one you can do very fast. Okay, so which of the following shows the correct state at 100 degrees Celsius? Where is 100? Where's 100? Can you see how I did that? Because after 44 is 100, then 280, right? Okay, am I right? This one 100, then 110, then 180, right? So this area will be liquid, this area will be gas, because this part has passed the boiling point already. For example, L will boil at 180 degrees, which means at 180 degrees, it will turn into a gas. It will turn into a liquid at 110, and it will still be a solid at 100 degrees Celsius here. So L will be a solid, whereas K will be a liquid. Liquid. No. Am I right? See? So answer will be number 5, D. Very easy. So I can go past this very fast. This one, can you look at the heading here? Here, multi-processor question, which means it takes a little bit of effort to find the answer. You can get tricked very easily. You must be careful. Okay, which of the following is definitely true? You need to read. Okay, which of it is definitely true? The boiling point of a substance C is 40 degrees Celsius. Now, very hard to know, no, because let's say look at substance A first. Okay, it's solid, solid, solid. That means it hasn't melted yet. Its melting point is more than 60 degrees Celsius. Am I right? Hasn't melted yet because it's still all the way solid. How about B? Okay, it's solid, solid, then liquid A. It changes into a liquid over here. So the melting point is over here, somewhere between 40 and 60. And what about here? Its melting point is over here, somewhere between 20 and 40. This is how you have to see the melting points. Whereas the boiling point is all above 60 because all of them have not become gas yet. So you can't tell. You can't tell. You don't know. So all the boiling points for all three, for A, B, and C, is above 60 degrees Celsius. This is the notes that we can take. Okay, now we read. The boiling point of substance C is 40 degrees. No, because it's above 60. The boiling point of substance B is 60 degrees. No, you haven't changed to gas. Oh, sorry, the melting point. The melting point of substance B. Okay, melting point of substance B, go back here. Between 40 to 60, it's not exactly at 60. Because at 60 degrees, it is a liquid. But who knows it changed at 60 or at 50? We don't know. So it's not definitely true. It could have been 50. So the answer, melting point is between 40 to 60. That's why it's not exactly. So is it definitely true? No, not definitely true. It has the lowest freezing point. Freezing point. Not sure. Let's see D. Substance, because this one talking about freezing point. We haven't talked about freezing point here. We're talking about melting point and boiling point. Substance B has a lower boiling point than substance A. Based on this, all of them have a boiling point above 60, which we don't know the exact number. 61, 62, they can be lesser, up, higher, we don't know. So not true, we don't know. We don't know. It's definitely not true. So C is the only one that, C has the lowest freezing point because it is the same as the melting point. And the C does have the same or the lowest. Okay, I'm going to highlight that. I'm going to change to red. Look here. It has the lowest melting point because B has a higher melting point and A has the highest melting point. So C is the lowest melting point. Very true. Lowest melting point, which is exactly the same. Okay, we are testing you this. That's why it's a multiprocessor question. Melting point of any substance is equal to its freezing point. No difference. No, then you will not have found this one. Okay, so that's why multiprocessor, you must know this. Jessica poured equal amounts of liquid W and X at room temperature into two containers. The containers were placed in the freezer for 12 hours. Okay. After 12 hours, she took out and then immediately tilted the containers and found that A has become a solid. That's why it maintains its shape. You know, right? If it's ice or solid or whatever, it's because it's liquids W and X. It's not water. Take note. Not water. Okay. So what should be the answer? I'm leaving it to you guys to tell me. Okay. Answer is based on the what do you observe? What can Jessica conclude about the freezing point? Okay, very good. I've given some of you time already. The freezing point is lower than 0 degrees. Now, this is not water. That's why I say it's not water. So it couldn't what? Freeze at this temperature at 0 degrees because she put it in 0 degrees only. Okay. Whereas the other liquid was placed in the freezer, it froze. So what was the temperature at which it froze? We don't know, right? What do I mean by that? Trivia question. What is the freezing point of liquid W then? If you can answer this correctly, and that means you're a really good expert already. You can leave my lesson because it's already 4 o'clock. If you want to go for something else, you can go. Okay. And those of you who want to stay for the last 2 questions, you can stay because I still have 2 more questions. Okay. What is the freezing point on liquid W? I've got one answer, but I'm waiting for all of you to answer. This one you really have to answer because I want to see whether you understand or not. This was not in your homework, right? So it's important. What's the remember started at room temperature and it's not water, so why would it be 0 degrees Celsius? It could have frozen at 5 degrees Celsius, right? Its freezing point could be 5 degrees, it will still become a solid. Its freezing point could have been 10 degrees Celsius. Its freezing point could have been 1 degree Celsius, could have been 0 degrees Celsius also. It could have been anything between 0 degrees Celsius to room temperature. Because as long as you cool it, it's going to freeze. Okay, so she put it in the freezer, and temperature is below, at room temperature is liquid, but below room temperature, we don't know, it could be 21, it still could be the freezing point liquid W. So my idea is this, between 0 to the room temperature. This answer. Okay, there's no other answer acceptable. You have to put this answer. Okay, if you want to know why is this, you think through it. Okay. Question, part B of the same question. Based on the above information, ice pack, and this ice pack was put in 0 degrees, similar to that one, because it was liquid W. It does not freeze at 0 degrees liquid. You must realize that. Whereas here, because it's water, you actually picked it from your tap, it's become ice. So, because this is water, this is not water. This is a liquid. We don't know what liquid. It's a liquid like this, from the previous part W, right? Which is not freezing, so it doesn't become solid as liquid. So, however, the temperature is cold because it's 0 degrees. It is soft. It's still cold. I put it on my forehead and I feel relief. I feel pain-free. Okay, I can use it for my fever. However, I take the ice. I'm so uncomfortable. It's so hard. I can't make it fit my forehead. So that is the reason why a liquid at 0 degrees Celsius is much better. So we will choose a liquid that freezes, doesn't become below 0 degrees. That means it doesn't become solid, it just stays as a liquid. Take it out and it's still a liquid, but it's very cold. I want cold. Okay, so that's why it is more comfortable to use ice pack P. Okay, that's what I've written down here. Okay, these notes will be sent on my website with the answers. You can actually copy it down later. So no worries, the answer is very long. You can copy it or download it later. Okay. Right, the table below shows 4 states. Now, this is the question where we have the melting point thing, but we did not tell you the melting point, boiling point. You have to figure it out, because we tell you at 25 degrees, it is a solid. At 50 degrees, it is a solid. At 76 degrees, it is a solid, which means it's similar to one of our MCQ questions. Okay, don't worry, I'm going 5 more minutes. The lesson is going to end, because after I discuss and the question of a quiz where I'm giving out the prizes next week. So you might want to stay tuned for that. Okay, just want to let you know before you leave too soon. Okay, look out for the quiz at the end. It's a very important exercise that I want you to do during the weekend, and I'll pick the best answer for receiving the prize from me for next week's lesson. Okay, so the boiling point is more than 76. Am I right? Can I write this statement? Because, or even the melting point, because it hasn't even melted, right? So we can write A for B, for C, and for D, and then we can compare like this. Now for B, okay, we write what? The melting point is between 50 to 76, because it melts here. Oh no, boils. So boiling point is, okay, boiling point is between 50 to 76. Can you see that? Because it boils here. In between, it doesn't, we don't know what the temperature is, so I write 50 to 76. And then what about it melting? Melting should be somewhere here. We don't know, so is less than 25 degrees, but we don't know. So I can go on and write these details, and I'll get a table that looks like this. Clear? Okay, so this is the table that summarizes that. Okay, similarly for D. So if I have all this, now I can write down my answers. Okay, to whether it's true, false, or not possible to tell. Substance A has the lowest freezing point. Okay, let's look at the freezing point. The lowest freezing point is B and D, so it's false. Substance B is a liquid at 70 degrees. Substance B, let's look at B. I'm here now. Is liquid at 70 degrees. Its boiling point is from where? 50 to 76. We don't know when it boils. Maybe it will boil at 70. So it will be liquid. Maybe it boiled earlier at 50 degrees. So it's not possible to tell, because it's a big range here. Okay. And then C, the melting point for C is 30 degrees. Melting point for C is 30 degrees. A, the melting point, we are not sure. How can you say exactly at 30? It's between 25 to 50. So I can't tell also. Okay. Substance D has the lowest boiling point. Substance D has the boiling point. Huh? So we have to look at this table. This one is 76. This one is 50 to 76. This one is more than 76. Oh, this is the lowest. 100% can tell because these are all higher. This will be more than 76. This will be between 50 to 76. This one will be between 25. It's definitely lower than B. So true. Okay, these are the answers. Okay. So having that information in the diagram, draw how substance C will look like when it is tilted in the cup. Okay. When it's tilted in the cup, so we're going to focus on this only. At 60 degrees, what is it? At 25 to 50 is melting, freezing. It will boil at more than 76. So at 60 degrees here, it will be a liquid. Therefore, if you tilt it, it should do this, right? It should do this. Am I right? It should conform to the shape of the liquid. Good. It's the toughest of them all. Probably take a little bit of time for 4 minutes. So if you have time to watch this, it's very important. Just stay with us and let's go through it. Okay. Now, one of the key things that you guys like to say is this: nothing happens. We already asked you what state the process. Okay. If you are very familiar with this kind of diagram, A and B is staying at 0 degrees all the time. Remember? And you know when it's staying at 0 degrees all the time, there's a process going on. Until it changes from full solid to the full liquid, it will stay at 0 degrees all the time. Then it starts to move. Therefore, the process of melting is happening. So you cannot write nothing happens, you have to write melting. And then here is liquid all the way, it will boil. So it will stay at this temperature until all the liquid changes to gas, right? So boiling is taking place at C to D. So that's why melting and boiling. Some of you wrote nothing happens or no temperature change. This is the misconception which you have to. Because of today's lesson, you have figured out that even the temperature can be constant at these two temperatures, which is the fixed point of boiling and melting. Melting is happening, boiling is happening. So this is the process. Okay. Next question, even more important, even more confusing. Did the ice cubes gain heat from point A to B? Here, a lot of students say no. Okay. No, because the temperature is the same. Am I right? How many of you say this answer that I written? You wrote this. Okay, the temperature is the same. Okay. Now, if the temperature is the same but no heat is being gained, then how can the ice continue to melt to become, like melted ice, more and more water? Heat is gained, then only melting can be occurring. So if you already said melting is occurring, heat is. So you don't see the temperature, see the process. The process, heat is being gained. Did the ice cubes gain heat? Yes. Okay, don't say no. Why? Because now you see the new answer. Change the answer. Heat is gained from the heat source. It could be room temperature. If you are heating it up, okay, she heated up, she did. If you are heating it up, is gaining the heat from the heat source. Heat source, gain heat. Okay. However, even if you did not heat it up, you leave it out in the room temperature, it's still gaining heat from the surrounding. So these are the two things that you need to take note of. Now, without removing the heat source, what could Amanda have done to her experiment at point D? Because point D, the 100, it's supposed to stay at 100 and become steam, right? Remember? Then if you leave it to cool, remember it's supposed to jump to the 50 degrees straight away. It should go in a curve. If you leave it on the table, over time it should curve like this. Okay, always have a curve like this. However, it goes straight down. That means she did a drastic change of immediately cooling it 100 to 50 in just, it's very fast, it's cooling. Usually it will take very long to cool. So the curve may be like this, take very long, but it's not. She's cooling it drastically. So what did she do? She must have put some ice or remove the heat. Okay, so those are the only two answers. Okay, she must have added some ice to cool it so fast, or put it in the fridge. Did she put it in the fridge? Okay, or she must have she didn't remove the heat, so you must take note of this. She didn't remove. I said, oh, she must have removed, but I'm wrong, because without removing the heat, what did she do? She could lower the intensity of the heat. Okay, then less heat gain. Okay, so over time it actually cools down. It doesn't stay at 100 anymore. Okay, now I think this is the final one. One big block of ice, is it easier to melt, or is it easier to melt small cubes of ice, both of the same mass, cut into small pieces? Which one will take faster to melt? You try it. If you have a big block, how do you make a big block of ice? Put in one container and put in the freezer. You get one big block. And then if you cut them up, the same mass results. Okay, she'll observe that the time taken for the smaller cubes will be faster. Okay, the time, because it has more surface area. Okay, just imagine this. I draw again versus them together. Because the surface area is only this much, whereas this one, the surface area, I'm going to draw in yellow, is here using a mathematics calculation is actually a lot more. So it can receive more heat in all surfaces, absorb this heat faster. Whereas here, the surface area that is hidden inside, inside fast. Okay, so that's the reason why the time will be shorter. So this one you would write. Okay, we didn't really ask you explain. If we say explain, that is actually a higher order. In P6, we will ask you to explain. Then you say the surface area. You bring the concept of the surface area. Here we did not in this question, so take note. Some of you like to over enthusiastic, even write this. But we didn't ask you, you write, you waste time. The PSLE, you're going to waste time writing things that we didn't ask you. Then you will have lack of time to do other questions. So that's also a point. Okay. So next week, I'll see you on Thursday, not Friday, Thursday. I've actually put the schedule up already at 3 o'clock. And I have a small quiz for you to do during this weekend. So if you have a phone next to you, pick it up, take a picture of this. I will put it up, but it will only come up tomorrow in your website. So by today, if you want to start it, you have to take a picture of this. Go to your mom, say, Mommy, I need the handphone right now. I need to take a picture of this before this screen goes off. And then do this and send me your best answer. The best answer will be selected to receive one prize that I will give out next week. I'll say who's the winner, because I want to know how well you do this question. Okay, so where are the answers supposed to be sent to? This WhatsApp number. Okay, send it. Just take a picture of your answers and send it to the WhatsApp number over here. So the best to actually screenshot this. If you don't have a phone on hand, don't worry. I'll put this up on the website for next week's lesson material. So when you download the homework for next week's lesson, you will see this there as well. All right. Okay, so I can end the meeting and hopefully I see you next week. Come back because we will discuss this homework and see who won the mega prize. Ta-da! Okay, see you, bye.